And that somehow it's relied on federation capabilities that we have another session of federation that really the actual mechanism how to federate the MDSAL, and the federation manager will utilize those capabilities. Over here we wanted to discuss about the federation, more about the federation manager itself. It's more about a network federation manager, and some of the capabilities is just a pure network capabilities that are good even without federation. So, in basic, why we created this federation is to allow multiple Openstacks, multiple sites to share the same networks. So if you have, for example, 3 sites, A, B, and C, each one has a different, its own network. You want to say that the orange networks and the blue networks will be the same network between different Openstacks. Okay? So that capability is not existing between Openstacks because each Openstack is its own environment, and you want to federate them all together. So to create some kind of a ubiquitous networking between the location. So we had to use the deluxe GUI for that because it's beyond the OpenStack scope. It's not in the Neutron API, it's beyond them. So we put it in part of Open Daylight API. And the resources are across the site. You need to configure them. And in addition, you need also to manage them. Okay, so you want a consistent view of that networks between the location of the different sites. So how it looks from an ODL perspective, just to be sync between everyone. And we'll start with the presentation, and then we can go to discussion. So I just want to sync on the knowledge about with all the team. So the left side is a regular Neutron ML2 networking ODL, whether it's V1 or V2, that you're familiar with that, calling Neutron northbound, update the MDSAL, and network communicate with the NetSAL event, okay? Obviously, network activate OVSDB and OpenFlow, goes to the OpenFlow switch, and that's enabled the Neutron networking, okay? Now, I want to federate that, okay? So we use the federation platform, which is another discussion, which is just, you can think about it as a messaging bus, okay? With a filter, get and register capabilities between the location, okay, of the MDSAL. And the federation service decides of which the network federation plugin decide which objects of the network he will replicate or send to which site, okay? So the network federation plugin he is network aware, okay? He knows when the other, okay, we'll get to that. So from the top level view, the orchestration tells orchestration or GUI tells the federation manager which network to federate. The federation managers talk to the federation plugin and says like which network needs to federate. That's how the federation plugin knows that which event do I need to send to other site. Okay? If you have any question, if it's not unclear, I can answer. So I want a federated tenant to be mapped to a different location. I do a register of the other sites to me. Okay, that one I'm federating to them, and and every update that I have in my, I get, for example, a new VM coming into my Openstack, okay? And a new port comes up, okay? The port is in the NetVirt model. The federation gets that port. If there is other side that needs to know about that port, then he will send it to the federation, and the federation will transfer the information to the other side. So there is kind of a filter which is NetVirt aware to say which event goes to which sites. So what's that create from a model perspective? So each side, for example, over here, the pointer. Okay. Each side has its own NetVirt model, okay? In NetVirt you have OVSs, VM ports belong to a network, okay? So this is the view of abstract view of NetVirt in one side, and the other side, and the third side, okay? So that's the abstract view. It can be a cluster of ODL, or it can be a single instance. You don't care, just the model, okay? What happens if you want to federate those network, the blue and the orange, okay? So we created a shadow instances of those ports and the needed OVSs in the other side, okay? So created those shadows for each one on the other side, and they register on the changes, okay, for that specific network. So if it's a new port we'll create it for that federated network, it will be notified to the other side, same as delete and all of that. So it created a shadow, and each site knows about the others. And we created a tunnel between the different OVSs as needed based on the network usage. And you have the VXLAN. So, we don't have the joint. So complete solution will have a connection as needed. It looks like it was a single site. Okay? Now,
show it the demo itself.
Yeah. So we have the demo also part. So this is the downstream code that we are gonna upstream that into Carbon. So immediately after the DDF, that we'll push that code. And what we created is a few capabilities in the cross-site. Some are good for a cross-site, but some of them, even for a single site, are good because we added capabilities to visibility into what's going on in the network. Yeah, yeah.
So, can you hear me? Okay, so as Ariel mentioned, and the purpose of this Federation Manager, we had two use cases. One of them is to configure the connectivity between the sites, and the other one is for monitoring and troubleshooting what actually happened in the site. So we start with defining the site, which site we want to use, and how to get the information from. So when you look at what we have over here, the top table actually defines a list of sites. Okay. Okay. Maybe the pointer guy. And we define here the set of sites that we want to manage, okay? For each one of them, we define how to connect to the Openstack in this site and to one of the ODLs, which we assume it's a cluster and you can reach in any one of them to get the information. Each one has its own credential and we fetch the relevant information from each one of them. The bottom table defines federated tenants, which is something that's relevant only for the federation manager. It doesn't propagate to any of the sites. It's something that we use in order to be able to assign a specific tenant from the site to something more general. And if you look at the configuration for each one of the sites, each one we fetch the tenant from the Openstack and attach the federated tenant into it. So in this example for site 1, host 1, we are using federated admin to manage all the network and all the network information that was created by the tenant admin in this Openstack.
We wanted to preserve the same logic is an Openstack, that you have a user in the Openstack, the user belongs to multiple tenants, and each tenant has its own networks, okay? So we created a user in the federation. In the user of the federation, it has its own federated tenant, and you need to associate a federated tenant into each Openstack tenant that you have. Okay, so you need a credential for that Openstack tenant that you need the ODL to read from and to decide that association.
Okay, so go to the second tab.
So this is more as a one-time configuration per user in a tenant. Okay.
Okay, just select one of the tenants in the combo box, or go to the second tab. Okay, so for example, if we select the federated tenant that called federated admin, it means that all the network that was created in all the sites that relevant to this, that was assigned to this federated tenant, all of them exist over here, and it allows us to connect and have the connectivity between the sites. So we pick one of the subnets, it automatically propagate from the site, the federation manager query each one of the ODLs, get the list of potential networks, collect them over here, and from now on we can connect a specific subnet to have the connectivity between them. So if you just open one of them, okay. By selecting the specific site that we want to connect and click on the collected site, the federation manager will send an RPC, invoke an RPC on each one of the relevant sites, and then this RPC will say, okay, I want to add the NetVir model in order to have the connectivity ready for having flow that runs between the sites. Right now we have already configured subnet 2 and subnet 3, and as you can see we have also subnet 1 which is not connected. And let's go to the network topology. Just select one of the tabs that already opened. It's the second, other one. This is the physical. Okay. As I said, we have the configuration side and we have the monitoring and troubleshooting side. And the network topology tab over here help us to do some maintenance on the network. We have physical, that is moving right now. The physical is actually, we are showing over here the OVSs in each one of the sites, and any links over here is a tunnel that is configured between the OVSs. Right now we have a full mesh, so this is why you see a lot of links between them. And they are all aggregate under the site, so and you can see which sites are connected to which other site, which other OVSs is in the other site. And each one of the links representing two endpoints of source and target.
Yeah, and if we are on the DDF, so we want to add capability over here, is that to see the counters of that specific link. and even up to open up a Wireshark on that specific link, okay? And it needs to be tenant aware. So admin can see everything that goes, but if I'm a user that is not admin, I'm only should I be able to see only the traffic that belongs to my tenant, okay? And we still want to do that on a VXLAN tunnel that run everything. So I should be able to see only my counters that I'm affecting those tunnels, and only my traffic of a Wireshark, of that traffic that belongs to me. And that is a little bit requiring a little bit addition to current network model of creating additional counters and additional marking of things that going into the tunnel.
Okay, what we already have, so go to the logical, the other tab. Okay, and I arrange it, so don't move anything. The logical view is actually representing the network themselves, not the physical stuff, the network. And as you can see, we have in each one of the sites, we have 4 networks, the access, the external, real. It was arranged perfectly until you touch it. Okay.
But now it's working. I used the remote desktop. It was slow. So
yeah, because
now I can play.
It's late in Israel, so it's still working. And so what we have here, it's aggregation. We have aggregation of sites that aggregate the set of networks that defined in this Openstack site. Every time I look around, I see something else. Okay, to remember the location, so it's good. And for each one of the network, we have the IPs, the port that attach to this network. So in this case, we have 5 VMs, 5 VM ports, neutron ports, actually each one of them, and that belong to this network. And for troubleshooting, now you can click, okay. Right here we see the counters on the port that goes to this VM, actually to this specific VM ports. And you can see the counter that increasing. We're actually fetching the information from the OVS itself, getting to the flow and just get the statistic from it. And we have the rate graph on the side. This is for counters. And if we'll open, I don't have the Wireshark open, but you can show it in the presentation. If we start a tap, the traffic that goes to this VM will be forwarded to an OVS, which is located in the Federation Manager ODL. And we are also using ODL for to run the Federation Manager. And as you know, there is problem to expose the traffic when you are using DPDK. So we have an OVS on the Federation Manager, which is non-DPDK. And on the port over there, we are using Wireshark to expose the traffic to, and we are using TCP dump to expose it to Wireshark. So we have, if you start the tap, the traffic of this VM that goes in and out for this VM will go, we can see it in the Wireshark. Okay.
Yeah, you can. Try to open up the Wireshark by the remote desktop. You're connected to the VM, right?
Yeah. No, it's not there. This is not an IP as far as I know. No, it's maybe IPv8 or something.
Can you also this using data in the physical view?
In the physical view? Yeah, right now we already implemented the counters for the VM ports, okay, but the plan is to have it on tunnels, on physical, maybe to get it from the machine itself. But as an example for this demo, just implemented for the VM. But basically, it's just an additional RPC that know how to query the information, and everything from northbound from that should be the same. So still have time? Or?
Does it allow both L2 and L3 connection between the sites?
Yeah, actually, between the nodes, we are using VXLAN tunnels. So basically, any traffic that you can have in a single site is the same as going to another site. So basically, layer 2 or layer 3 doesn't matter.
Let's assume like in site A, you have a network with some subnet, and in site B, you have another network with the same subnet.
Mm-hmm.
So the up can go through.
If you have a router, let's say you are working a single site, you're supposed to have a router that connects between it will work the same over here. You should have some kind of router between them, okay, that know how to transfer from a specific subnet to another one. It will
But
still work.
In the same subnet, you don't need a router.
I don't need a router. It's a layer 2.
Will go through the two sites.
Yeah.
What is the relationship between the Openstack side of it and the ODL? Everything is actually federated at the ODL level, so
Yeah.
multiple instances of Nova, right?
Yeah, each site in terms of Openstack, it's a separate standalone and
So extending that question, if I would have the same subnet, but it's actually managed and provisioned by two different instances of Open Daylight, how would you,
the Openstack.
how would you actually coordinate between them? The handles for the tenant ID, everything is actually going to be different because Openstack is not aware of the federation. It's only Open Daylight that is aware of the federation.
Yeah, so basically you can have a problem if there are conflict between but the one that wants to connect these two sites should be aware of these conflicts and solve them separately.
Not actually getting the same tenant ID on two different instances.
Yeah, tenant is not something that ODL is aware of.
Yeah, but you want to enable the same tenant to.
No, so you have a federated tenant. It's a logic that it stays only on the ODL because we don't want. Basically, we could have said, okay, this network and that network connect, but how do you know that you have a permission to connect them? We want it to be not just admin level, also to create to remain with the same roles as Openstack has, which has users, tenants, authorization. So, for example, if you have federated keystone, okay, between the sides, then we can connect to a federated keystone, and that's it. You're done deal. What we wanted to also to be able to do that is not to enforce that capabilities, okay? So even if you don't have a federated keystone, just say on the level of the ODL, saying like, here's the username password for this OpenStack, this is the username password for this OpenStack, read the permissions that I have in each one of them, and then expose me my networks that I have in each one of them, and let me choose which one I can connect.
No, I understand that, but it really behooves you to replicate the kind of role-based access control that you would have with Keystone in a federated Open Daylight, because otherwise you'll have the weakest link in the chain in terms of authorization authentication.
Yeah, we totally agree. Keystone Federation is better, okay? We just, if there is Keystone Federation, we'll connect to that. But
it's not there yet.
There's at least one more solution. It could be Keystone Federation, and the Open Daylight stuff is kind of to show a full solution, but it's not really a production solution. And the third solution is to have really manage your multi-sites using an orchestration system, and have your tenants and users in the orchestration system. And that orchestration system could possibly access the OpenStack sites just via a single user, like admin type, and have all the enforcement and the gatekeeper between the orchestration. Same goes for IP allocation. So if you have two networks in the same subnet, and you want to make sure that they don't allocate the same IP address to two VMs to different sites, then what you really need to do, or would probably want to do, is have some kind of IPAM solution, which would be at the global level, which would control the DHCP on every one of the sites separately. So the full solution in production is a little bit more complex than this. But this platform enables the sharing once you've taken care of those aspects.
Excellent. That puts it in perspective.
So use this with any
solution.
What we're showing here is that even if you manually configure every site separately, then ODL has the capability of connecting them, but it's under the assumption that you can actually do that sharing without conflicts. So that's something that ODL in itself cannot take care of because it's already existing.
Okay, just what is the current status and where we want to go. Okay, so the current status is actually this one. Okay, the capabilities that we already have to connect the site, to show the site, monitor and troubleshooting as the example that I showed. As Ariel mentioned, most of the code right now, it's downstream code, okay, because we start working on that in the middle of Born and didn't want to expose new API and changes and major changes. The plan is to upstream everything to Carbon, both the federation and the cross-site manager, the UI. This UI is based on Next, which is something which is available as part of ODL. And of course, to improve it, make it more reliable and stuff like that. This is the plan that we have for now. That's it. Any question are welcome.
Just one
Yeah.
more thing. So, can you maybe describe in few words what is the way you're interacting with neutron right now? Because I'm personally definitely interested in the problem of multi-site. The trick is, well, I have one entity that, like what you have over here, that potentially can control the network in multiple sites. But then I also need to interact with whatever local Openstack entity I have. So what is the approach that you guys are taking now, or what would be your long-term approach when you feel it's like a full product?
Okay, so what we have right now, okay, our plugin code, the NetWeaver plugin code, is basically listen to MDSAL changes of neutron ports. Okay, neutron ports or interface from Genius, it doesn't matter. And once it gets this notification, the NetWeaver plugin federate the information using the federation service that we have a different session on. But let's assume there is a magic that federate the information from a specific port that was created in one side to all the other sides. Now the shadow nodes and shadow ports that created in the other sides are get into the MDSAL of the other ODL, and like the same way that it came, the same as it came from Openstack that configured through the northbound. So once you have the MDSAL ready in the other side, anything should work the same. So port will be configured, tunnel will be automatically configured if it needs. Everything is supposed to be the same. We are using the same mechanism of NetWeaver, just inject some data into the MDSAL and let him continue from there. This is the.
So for the actual federation part, there's no change. Okay, whatever networking ODL provide, V1, V2, we use that, it's good enough. The only thing that we need to extract from Openstack is for that GUI to have a user role responsibilities that's currently not provided by ODL, okay? And we approach the Nova API to get that information. So that's something else that we build in order to expose the relationship. But that's something separate.
As the other person mentioned, you also need to have federated IPAN if you want, so that you would not. Otherwise, the default has to be that you really have some routing in between, and you're dealing with IP address duplications and all of the other fun stuff, and that's going to be very good.
Yeah, so we should have some kind of orchestration, something above us that control these conflicts. We don't have a.
Just limit the manual.
Yeah, what we did over here manually.
Yeah.
They can do it manually.
Manually, you
Be aware of it.
Yeah, but since it's a centralized code, okay, you can say that one of the sides can return an error if you identify a conflict. So, and I don't know, you can, I'm not sure you want. and I don't know, block the federation and block the between site connectivity, just to make sure there are no conflicts.
Is there a plan for a CLI for this?
Everything is it's based on ODL, so you have an Karaf RPCs. So yeah, this is the CLI, and everything is REST-based. It's just
Just like accessing the counters.
It is. Any RPC is also a CLI-based and JSON REST-based. You can invoke it from any way you want.
So you mentioned about automatically set up the tunnel. Where is the tunnel created against?
And they're in NetVirt, the code in NetVirt, which is we based on. And there is an automatic tunnel creation, which is any node that belongs to a specific network, all the nodes of a specific network, NetVirt will create a tunnel, a mesh tunnel between them. So once you create a new VM, attach it to a network, the node of this VM will be part of transport zone. This is the name of the genus object that manage all the tunnels. And all the endpoint in this transport zone will have a tunnel between them. This is an automatic. And it might be between sites. Once you have the endpoint of the IP of the OVS that from the other side, you just create a tunnel into it.
And you would have the requirement, like you have this line between the sites, you can use just a public IP.
Yeah, it should be. It's a VXLAN that must have connectivity between the two sites. It's the same. Why it's double?
The tunnel is like within the site. If you use the VXLAN,
it's the same. Just yeah, it's the same VXLAN.
So you can put your the IP address of the VXLAN in a public IP if you want,
or private.
That you can go through the internet, or you decided to have a VPN in between. That's separate. It's deployment discussion.
If another site is not using VXLAN, using VLAN as the network, so you still can between the two, still can connect.
So it's Openstack stuff. VXLAN to VLAN not exist in OpenStack. So
You have to have the same.
you have to have the same provider for that VLAN.
And
For that
VNI
segmentation.
should be the same.
What?
Yeah.
VNI should be the same.
Yeah, if you want a VXLAN to VLAN, you use hardware VTEP, okay? And you can. So that's, you have to put in the other side, VXLAN, hardware VTEP, and then goes back to the VLAN. So you can do that. But that's a separate solution, combining a separate solution together.
No, but even if they use the same provider network type, the VNIs at different sites may be different.
Yeah, maybe
right?
different.
How do you transfer between the VNIs?
So
the federation.
That's a current limitation in the NetVirt implementation because the VNI goes through the network, and but it's solvable.
So the assumption is the tenant, the network VNI should be like always.
At the moment, there is a bundle between segmentation ID and the VNIs in the current NetVirt code, but that can be fixed. So that's we're planning to fix it in Carbon, and you can have a different segment ID in each location.
So we need to finish because other.
Okay.
Sorry.
It's a question.
Right now, we don't look into the segmentation ID. We don't look into the VNI. The only thing that's required is that it has to be within the same transport zone for us to build a full mesh. For the VXLAN mesh, the tunnel that you was talking about.
You're saying for creation of the tunnels. Yeah, but I think you mentioned for the traffic itself to allow the other side to accept this one, you must have the VNI in the other side.
Right.
And this one is federated by the federation. So the other side is aware of the VNI that is used. Okay, thanks.
Thank you. And that's somehow it's relied on federation capabilities that we have another session of federation that really the actual mechanism how to federate the MDSAL. And the federation manager will utilize those capabilities. Over here, we wanted to discuss about the federation, more about the federation manager itself. It's more about a network federation manager. And some of the capabilities is just a pure network capabilities that are good without, even without federation. So, in basic, why we created this federation? Calling neutron northbound, update the MDSAL, and network communicate with the network event. Okay, obviously network activate OVSDB and OpenFlow, goes to the OpenFlow switch, and that's enabled the neutron networking. Okay, now I want to federate that. Okay, so we use the federation platform, which is another discussion, which is just you can think about it as a messaging bus. Okay, with a filter, get and register capabilities between the location, okay, of the MDSAL. And the federation service decides of which more the network federation plugin decide which objects of the network he will replicate or send to which site. Okay, so the network federation plugin he is network aware. Okay, he knows when the other. Okay, we'll get that. So from the top level view, the orchestration tells orchestration or GUI tells the federation manager which network to federate. The federation managers talk to the federation plugin and says like which network needs to federate. That's how the federation plugin knows that which event do I need to send to other site. Okay? If you have any question, if it's not unclear, I can answer. So I want a federated tenant to be mapped to a different location. I do a register of the other sites to me. Okay, that one I'm federating to them. Is to allow multiple Openstacks, multiple sites to share the same networks. So if you have, for example, 3 sites, A, B, and C, each one has a different, its own network. You want to say that the orange networks and the blue networks will be the same network between different Openstacks. Okay, so that capability is not existing between OpenStacks because each OpenStack is its own environment, and you want to federate them all together. So to create some kind of a ubiquitous networking between the location. So we had to use the deluxe GUI for that because it's beyond the OpenStack scope. It's not in the Neutron API, it's beyond them. So we put it in part of Open Daylight API. And the resources are across site. You need to configure them. And in addition, you need also to manage them. Okay, so you want a consistent view of that networks between the location of different sites. So how it looks from an ODL perspective, just to be sync between everyone. And we'll start with the presentation and then we can go to discussion. So I just want to sync on the knowledge about with all the team. So the left side is a regular neutron ML2 networking ODL, whether it's V1 or V2, that you're familiar with that.